सर
विकास सर ऑडिबल?
हाँ सर, ऑडिबल एंड विजिबल।
थैंक यू सर। मैं बस फोन करने वाला था आपको, लिंक
जी
करने
सर।
फिर मुझे लगा आप पहुंचने वाले थे। तो सारे लोग को लेना है ना सर आज?
हाँ सर।
सर एक बार शेड्यूल अपना बताएंगे सर, अभी का क्या है दोबारा?
सर पहला जो है वो क्या बोलते हैं, मूर्ति सर का रहेगा।
इंट्रोडक्शन?
हाँ सर।
जी सर।
और उसके बाद फिर शुभ्रा मैडम को आप इनवाइट करेंगे।
जी जी जी।
और फिर वो क्या बोलते हैं, जो धनंजय सर है उनको इनवाइट करेंगे।
ओके ओके। उनके बाद फिर दोगले सर भी है ना?
हाँ, फिर धोबले सर का है।
दोनों के डिस्क्रिप्शन में शुक्ला मैडम को इन्वॉल्व है।
जी जी सर, दे दिया हूँ मैं।
जी जी दे दिया ना, बता दिया ना उनको। ठीक सर।
हेलो हेलो।
हाँ सर। हाँ
हाँ
सर।
सर।
बनाया का तो टिकट करना पड़ेगा
क्या? है ना?
गुड इवनिंग।
गुड इवनिंग।
क्या चेक ऑडियो वीडियो चेक कर लेना विकास थोड़ा।
ठीक है भाई। धनंजय ठीक है, विजिबल भी है, ऑडिबल भी
है ना? हाँ ठीक है।
हाँ।
मेरा कैमरा ठीक है ना? मतलब लाइट से ज्यादा वो तो नहीं दिक्कत तो नहीं?
नहीं
क्लियर?
हाँ क्लियर है, क्लियर है।
तो एक बार जब मैं इंटरव्यू दिया था ना बिलासपुर यूनिवर्सिटी का, तो काफी एडजस्ट किए थे डिस्टेंस, मतलब ये टेबल से इतना डिस्टेंस रखो
अच्छा हाँ हाँ।
हेलो।
हेलो। हाँ मैम।
हाँ सर, आवाज आ रही है? क्लियर है?
हाँ क्लियर है, क्लियर है मैम।
जी सर। सर पहले धनंजय सर रहेंगे ना? डॉक्टर
जी जी
धनंजय देशमुख फर्स्ट
जी जी
स्पीकर।
जी जी।
ओके सर। जी सर।
इज क्लियर?
सर क्लियर।
क्लियर है? आवाज आ
यस
रही?
सर,
आवाज आ रही?
आवाज आ रही सर।
चलो मैं भाग जाऊं फिर।
जी सर, ऑडिबल एंड विजिबल।
चाय लेगा?
नहीं सर, आप लीजिए।
थैंक यू। अभी केवल 18 पार्टिसिपेंट बचे हैं।
हाँ सर।
18 पार्टिसिपेंट बचे हैं, बाकी सब भाग गए।
नहीं नहीं सर, वो अभी ऐड हो रहे हैं।
ओके, नो प्रॉब्लम।
जी।
एनीवे,
कल थोड़ा लेट से शुरू हुआ था ना सर, ऐड होते
हाँ
जाएंगे शुरू होगा तो।
ठीक है ना। कितने बजे शुरू हो रहा है?
4:30।
हाँ तो ठीक है, मैं 5 बजे तक वेट करता हूँ।
अजय सर, अजय सर,
सर
स्टार्ट कीजिए.
good evening to one and all. Respected all the panel members, the speakers, and the participants. A warm welcome to all of you on the day 3 session of International Webinar Series on worldwide effect of COVID-19 on research and development. This session has been started from 24th onwards. Day 1, day 2, we have completed successfully, and we are hosting the day 3, that is the last day session. Today, on the day 3, we are having an esteemed speakers, Dr. Dhananjay Kumar Deshmukhji from Chubu University, Japan, as well as Dr. S.J. Dhoble, Professor, RTM University, Nagpur. So before moving ahead, I would like to invite Dr. KVR Murthy for his welcome speech. Sir, please. Sir, please unmute your mic, sir. Please unmute your mic, sir. మూర్తి గారు మీ మైక్ ఆఫ్ లో ఉంది సార్, మ్యూట్ లో ఉంది, అది అన్మ్యూట్ చేయండి సార్. నథింగ్ ఈస్ ఆడిబుల్ సార్. I request the host, if at all it is possible, to unmute the panelist. Please proceed for that.
Okay, sir, I will try.
Sir. Vikas sir, any updates?
Sir, I have unmuted all the participants and
Yes sir, now it is unmuted sir. Murthy ji, you can come online. Hello. It's connecting audio sir.
Connecting, sir. Murthy sir, you are unmuted now. You can speak. Your frame is free, sir.
Sir, I suggest you to just remove the headphone. Sir, could you remove the headphones and once again try it, sir? Sir, could you remove the headphones and you can try it?
ख्वाजा सर
Sir,
सर वेट फॉर मिनट सर ट्राई कर रहे हैं.
okay, okay, sir. सर, मूर्ति सर, एक बार आप हेडफोन रिमूव करके ट्राई करेंगे एक बार? మూర్తి గారు, జస్ట్ యూ రిమూవ్ ద హెడ్ ఫోన్స్. మళ్ళీ ట్రై చేయండి సార్, హెడ్ ఫోన్స్ రిమూవ్ చేసి. Due to some technical issues, please keep 2 minutes. Deshmukh sir, Dr. Deshmukh sir, a warm welcome to you for this session.
Yeah, thank you very much.
And you have been joined from the initial stage itself. We are happy to see you.
Yeah. Actually, because 9:30 Japanese time, I have another webinar today.
Yes, sir. Yes, sir. We can understand the same just for 2 minutes, sir.
Yeah. No problem.
like
We
to
have
be
enough
connected
time.
very
It's
soon.
already 1 hour 30 minutes. I have time actually.
Thank you, sir. Thank you. I hope he has been getting connected.
Yeah.
Sir, Murthy sir, now also it is not audible, sir. Sir, remove the headphones. The host Vikas sir, once again you unmute the panelist, sir.
Unmuted, sir.
Sir is on mute mode, sir.
Maybe because of a headphone.
That's what Murthy garu ఒకసారి మీరు హెడ్ ఫోన్ తీసి ఒకసారి ట్రై చేయండి, డిస్కనెక్ట్ చేసేయండి సార్ హెడ్ ఫోన్.
Disconnected. Okay, Khwaja sir, can we go for Deshmukh sir session until this technical issue is solved? Can we go for it? Vikas sir.
I would like to take a permission from our host member, Dr. Vikas Dubey.
Sir will be joined with laptop
Okay, sir.
within 2
Okay,
minutes.
sir. Sure, sir.
Deshmukh sir, sorry for the inconvenience caused due to some technical issues.
Yeah, no problem, no problem.
I hope
It was first time for me in this application, so I was little bit afraid I can operate correctly or not, but I think it's okay.
you were the first to join, sir. You are comfortably okay.
Yeah. So still the institutions are closed there, right?
Yes, sir. Yes, sir. How about the situation of the Japan, sir?
Japan, it's a very good, I can say, because only 1,000 cases remaining over the Japan, and in our state we have only 20 cases.
Okay.
So that I want to, because the theme is very interesting, theme of this conference. So it vary to country. I think the impact
Yes,
is
sir,
not the same.
exactly. And the title, what you have been discussing today, is also very much interesting. The title is itself is known as what is COVID-19 and how it is having its impact on
because-
R&D activities.
Yeah. I was thinking little bit afraid because the same topic having several experts a presentation, and maybe it will overlap, but luckily last 2 days presentation was not more on that one, so it's okay now. It will be something new information with latest progress on these things.
Yes, sir. Yesterday also you were be one of the panelists.
Yes. Yeah.
Yes, sir. It was good that you are attended the
Yeah,
other sessions also.
because I during my PhD I work a little bit on that one, so it was a very nice lecture.
Thank you, sir. Thank you, sir.
In fact, one of my Japanese fellow, he came in the last moment. He wanted to join. I said, "It's going to finish."
Because, sir, any updates, sir?
Sir will connect it shortly, sir.
Okay, sir. For the kind information of the participants, the day 3 session is organized today. We had a wonderful sessions on day 1 and day 2. On day 1, the Professor Dirk
Yeah. Good evening to everybody. Hello.
Good evening, sir. Good evening, sir.
Yeah. Can you
Audible, sir.
listen? Yeah, good. Yeah, good evening to everybody. Can I start?
Yes, sir.
Mohiddin?
Yes, sir. Yes, sir.
Yeah, good evening to everybody. So this program in the COVID situation is organized by Government Science College, Durg, and BIT, Raipur. Basically, this program was started 2 weeks before when Professor Jagdeep contacted me. We want to organize international event. Then immediately they agreed, and we could contact few people, and finally this is possible. So this is mainly the backbone of this is Vikas Dubey and Neha Dubey. They their work leads to success of this event. First day, along with me, Professor Dirac, Associate Editor, Journal of Luminescence, spoke. Yesterday, Professor Chari and Sudapta Sen was there. Today, Professor Deshmukh and Professor Dobel, my friend, are going to be there. Overall, if you see the technical content of the this international webinar, is an excellently composed, and then we basically from Luminescence Society of India coordinated this event, and so many our members are also participants for this event. So the Luminescence Society is a registered body, a 30 years standing, and we have almost 850 members. Among that, earlier groups, if you consider from 1960, it was a Nagpur group, Baroda group, subsequently, and IIT Madras and IIT Kanpur, Kharagpur. Subsequently, mid-60s onwards, 70s, the Baba Atomic Research started this luminescence research, especially thermoluminescence, dosimetry, and others. So slowly, the luminescence work at Baba Atomic Research Center become minimum, and now the major centers are Raipur, Durg, Nagpur, Baroda, and Chennai, some, and Bangalore. Majority is concentrated in these places. And recently, Professor Anand shifted from NPL to NIT Warangal. So, if you see, less centers are there, research centers, but each center having 30 to 40 research students, especially PhD students and few postdocs are there, active group, and stray here and there may are there. So the majority luminescence research is thermoluminescence as well as photoluminescence, especially LED phosphor. So because of this COVID situation, last 3.5 months, we are sitting at Ideal, and as a president, I encouraged one company, Luminescence Society, Nucleonic Systems, to come up with a UVC-based devices. Yesterday they were released in the market, and an excellent device, simple device. Last 70 years, UVC was used, and now without any further. So that same device can be used in the classrooms, any administrative rooms. This is COVID is almost 40 where families of COVID viruses are there, especially. And from 1930 to 2020, it's 90 years history of this COVID is there. Recently, last week itself, Ahmedabad, Gujarat reported 20 variety of viruses. Even though 40 families are there, 20 varieties of a small city, around 70 lakhs population city, we found. So where we go, so how to treat? So whatever the drug we give, that may work on a few viruses of same type. But what about others? They have started multiplying. That is major concern. So recently I found 1918, this Spanish fever continued for 36 months and killed almost more than 5 crores globally. That is 5 crores is the official figure they reported, but unofficially it goes more than that. India itself 2 crores was killed or died due to this particular virus. Now it is targeted around a crore population is already affected, and we don't know when it will be subsidized. And coming is again rainy season. The rainy season is a boom for bacteria and viruses to spread. So one should care by keeping the social distancing. If you don't have work, it's better to stay at home or better to sit in our room. Don't entertain unknown person except your research student or your family member. Then only it will be safe. Once it is affected, we don't know whether really it is going to affect you or it will just surpass like that. And the present international webinar addressed many of these situation and discussed. And finally, I can conclude that the only social distancing, only solution to avoid this COVID. Okay. So thank you very much for giving this opportunity. Thank you.
Thank you, Dr. KVS Murthy ji. Thank you so much, sir. Once again, I would like to know that all the participants that the program has been hosted by Government BYT PG Autonomous College Durg and Birla Institute of Technology Raipur in association with Luminance Society of India. The current resource person, Dr. KVR Murthy ji, is himself a president of Luminance Society of India. Thank you, sir, for your kind welcome speech. Now I would like to request Dr. Shubhra Tiwari to give a brief description of our resource speaker of today's session, Dr. Dhananjay Kumar Deshmukh ji. Ma'am, please.
Thank you, sir, for giving me this opportunity to introduce speakers for today. A very good evening to all the eminent speakers, panelists, and the participants. The first speaker for today is Dr. Dhananjay Kumar Deshmukh. I was going through his gigantic CV and was engrossed in it. Dr. Dhananjay Deshmukh is postdoctoral research fellow at Chubu Institute for Advanced Studies, Chubu University, Japan. He has his PhD in chemistry from Pandit Ravi Shankar Shukla University, Raipur, and masters from the same university. He has a bag full of academic and research experience to his credit. To start with, Sir is postdoctoral research fellow at Chubu University, Japan from September 2014 till date. His areas of research includes, but is not limited to, assessment of sources and formation processes of primary and secondary organic tracer compounds and water-soluble inorganic ions in atmospheric aerosol and the like. Dr. Deshmukh's instrumental and technical skills includes aerosol particle sampling, high and middle volume sampler, and similar areas. Dr. Deshmukh has published 29 research papers, out of which 27 are published in international journal and 2 in national journal. He has a total of 630 citation. His H index is 15 and I-10 index is 19. He has been awarded Best Poster Presenter for 2017, JSPS Postdoctoral Fellowship Award from 2014 to 16 and 2017 to 19. Selected for Science Dialogue Lecture, Research Fellow Award from Pandit Ravi Shankar Shukla University, India. Full travel funding support from University of Finland. He has delivered a number of keynote addresses and invited talk at different colleges and universities, including BIT Raipur and Government BYT PG Autonomous College Durg. He is an eminent member of different scientific associations. Sir has visited countries like Japan, Switzerland, Austria, USA, Finland for academic and research purposes. He has scientific collaboration with universities of Hokkaido and Nagoya, universities from Japan, universities of USA, France, Czech Republic, Republic of Korea, Taiwan, China, Greece, Tanzania, IIT Kanpur, India, NIT Raipur, India, BHU Varanasi, India. Dr. Deshmukh is reviewer of international journals like Scientific Reports, Copyright Nature, Atmospheric Chemistry and Physics, Copyright European Geoscience Union, Atmospheric Environment, Copyright Elsevier, Atmospheric Research, Copyright Elsevier, Science of Total Environment, Copyright Elsevier, Chemosphere, copyright Elsevier. Environmental pollution, copyright Elsevier. Atmospheric, copyright MDPI. Environmental monitoring and assessment, copyright Springer. Aerosol and air quality research, copyright Taiwan Association for Aerosol Research. International Journal of Environmental Analytical Chemistry, copyright Taylor and Francis. Today, Dr. Deshmukh is going to express his view on COVID-19 and its impact on research and development. Sir, please, the platform is all yours.
Thank you very much. So I can share my screen now. So is it
Yes, sir.
visible, my
Screen
screen?
has been shared. Yes, sir.
Yes, sir. Visible.
Okay. So thank you very much for inviting me for this talk. And the topic of my talk is what is COVID-19 and how is it impacting research and development in worldwide. So these are the contents. Sorry, there is some problem or it is okay?
It's fine, sir. It's fine. Better it will be go for a full screen, sir.
Okay. Is it okay now?
Yes, it's fine. Completely fine.
So these are the contents. So I will talk about the coronavirus and the COVID-19. And within this topic, I will cover the species of coronavirus, the structure of this novel coronavirus, where we can understand the different segment of this virus and how coronavirus target its human cell. I will also talk about the stability and the viability of SARS coronavirus 2 on different platform. Being a student from chemistry background, I will talk about the role of chemicals in fighting this novel coronavirus. We will discuss something about the test which is available today for COVID-19 and the drug and development of new vaccine to fight COVID-19. And as the theme of the conference, which is mainly focused on the impact of COVID-19 in research and development, I will talk about the research and the development blueprint, which is given by the WHO. There are some funding opportunities due to this corona pandemic, and as well as I will discuss my topic of interest, which is air quality versus COVID-19. So let's start with the first slide. So what is coronavirus and the COVID-19? So there is a very small difference between these two words. That is, coronavirus is the single stranded RNA virus that causes respiratory tract infection, usually in the upper respiratory tract or lower respiratory tract, whereas COVID-19 is the name of the disease which is caused by the 2019 novel coronavirus. So how and where it was started? In late December 2019, there was a pneumonia outbreak was reported in Wuhan city, which is in Hubei province of China. Initially, doctor could not understand why this outbreak is happening. However, after some time, they came to know that this is because of the new type of virus, which is similar to the coronavirus. And that's why they named it as a 2019 novel coronavirus. This information was passed to the World Health Organization, and then after looking to the situation at Wuhan city and other countries, on 30 January 2020, WHO declared the outbreak a public health emergency of international concern. On 11 February 2020, they renamed this virus to severe acute respiratory syndrome coronavirus 2, or we can say in the short form SARS-CoV-2, by International Committee on Taxonomy of Viruses, who are responsible for the naming of virus based on the study of genetic material of the virus. So this is due to coronavirus. This novel coronavirus is named as a COVID-19 by WHO for further processing. So is this 2019 novel coronavirus is the first coronavirus? Of course not. There is 6 more coronavirus. Among 6 coronavirus, 4 were producing a mild symptom. For example, if you can see in the slide, human coronavirus OC43 HKU1229E, NL63. It produces a mild symptom. But the two coronavirus, which are Middle East respiratory syndrome related coronavirus that we call MERS, and second one, severe acute respiratory syndrome coronavirus that we call SARS, that produces a severe symptom. So this 2019 novel coronavirus is the 7th coronavirus that infect human. They found the 70% genetic similarity of this virus when they compared with the previous SARS coronavirus. And this is why the name of this coronavirus, they gave SARS coronavirus 2. Also, they found 96% similarity when they compared with the bat coronavirus. And this is the reason they are expecting that this novel coronavirus originated from the bat. If we will talk about the spreading, it is spread the same way as other coronavirus, mainly person to person contact. And because of the spreading, very fast spreading of this novel coronavirus, this COVID-19 quickly spread around the world. And then on 11 March 2020, WHO declared the outbreak of pandemic. So let's understand the structure of SARS coronavirus. You can see this is the structure, and I label the different part of this coronavirus. So it can be easily understood from the structure that it is a spherical in shape with some bulbous surface, which is because of the spike protein. And if you will talk about the diameter, the range is about 50 to 200 nanometer in diameter. The envelope of this virus consists of the lipid membrane, where three type of protein, that is envelope protein, membrane protein, and a spike protein are attached. The envelope diameter is around 85 nanometer, and the spikes protein, that is a very important part of this virus, is about 20 nanometer long. There is a nucleocapsid protein which hold a genetic material RNA, and this lipid bilayer together with the envelope and a membrane protein and a nucleocapsid protein, they protect a virus when it is outside the cell. So in this coronavirus, the first very important part is the spike protein that is responsible for the attachment of this virus with the human host cell. So let us understand how this virus targets a human host cell. So this is the coronavirus, and these are the spike protein, and there is a receptor ACE2 in the airway cell of human cell membrane. So because this number of spike proteins are very high in the case of novel coronavirus when they compared with the old SARS coronavirus 1, and this is the reason why this this coronavirus is strongly attached very fast with the human host receptor. So by the membrane fusion mechanism, it impact the human, and what we can understand from this mechanism is that the knowing about the spike protein could lead to the drug for this novel coronavirus. I read some article where I found that when they compare the number of spikes in this novel coronavirus and the previous one, SARS coronavirus, they found it is about in the average of 24. Now we can talk about stability and the viability of SARS coronavirus on different platform that make us that make everyone afraid when we go outside, when we touch some surface, or when we touch some metal or any solid surface. So there are some articles published this year. The first article published in Journal of Hospital Infection on February 2020 by some German group, and they studied about the stability and the viability of this novel coronavirus. They said that the SARS and the MERS can exist on any surface, like inanimate surface like metal or glass or even plastic for up to 9 days. This is the very dangerous actually report they mentioned, because the existing of this coronavirus for the 9 days on this type of surface like metal, glass or plastic, it could make us worry about the infection. However, they said that it can be inactivated within 1 minute by surface disinfection by using some disinfection reagents like 60 to 70% ethanol or other chemical. On the same topic, another paper came in the New England Journal of Medicine in April 2020 by some American group, and they said that this novel coronavirus is more stable on plastic as compared to stainless steel. They also calculate the half-life of SARS coronavirus, and they found that it was about a 5.6 hour on stainless steel and a 6.8 hours on plastic. They found that this SARS coronavirus 2 was measured after 4 hours, not measured after 4 hours on copper and after 24 hours on cardboard, whereas the old coronavirus, that is a SARS coronavirus 1, was measured after 8 hours on both copper and cardboard. They compared the half-life of SARS coronavirus 2 and the SARS coronavirus 1. They found in the aerosol and the copper it is similar, but the stability of SARS coronavirus 2 was more on cardboard as compared to SARS coronavirus 1. So how chemicals are fighting with the coronavirus? First, I will talk about the surfactant that is used in the soap. So this is the coronavirus, and the outer surface is the lipid membrane and other protein. And soap molecule has a generally two parts. One is the hydrophilic head and the hydrophobic tail. So hydrophilic, that is the water loving part, and the hydrophobic don't connect with the water, and it bond with oil or fat or lipid, we can say. So when we wash our hand, this soap molecule, hydrophilic head of soap molecule react with the water, but hydrophobic tail bonds with the lipid, and the tails group will wedge together into the barrier, causing it to break down, and then they release the fragment of the virus, and then soap trap the fragment of the destroyed virus, and then make one ball-like structure that is called a micelle that can be washed away in water. So in this way, how we can remove any virus from our hand by washing our hand by using the surfactant. Now another one is the hand sanitizer. That is very, very important. And during the beginning of this pandemic situation in India, when there was a shortage of this hand sanitizer, a lot of people purchase alcohol and some other reagents from the market, and they try to make a hand sanitizer in the home. It is a good actually, but sometimes it is dangerous when you have a when you don't have a sufficient understanding in what quantity you have to mix the reagent. So playing with the chemicals are not a good thing. So what are the WHO recommended hand rub formulations? So when it was a case was pandemic, WHO recommended two formulations. The first formulation contained ethanol 80% volume by volume, glycerol 1.45% volume by volume, and hydrogen peroxide, which was 0.1 to 5% volume by volume, and it was made in the sterile distilled water. They also gave a second formulation using isopropyl alcohol that was 75% volume by volume, and the glycerol and the hydrogen peroxide was the same as a formulation 1. So next one is the disinfectant. There is a two method, because we can use sanitizer for our hand, but if you want to clean surface, or if you want to disinfect the surface, we have to use a disinfectant. We cannot use a sanitizer. So there are two method of this for this disinfection. That one is the chemical method, where they use a vaporized hydrogen peroxide. They spray on the harder surface that oxidize and kill viral protein and then genetic material. In most of the cases, they use also diluted solution of sodium hypochlorite or powdered calcium hypochlorite. Another method is a non-chemical method where they use a device using a UV irradiation and to kill the virus. However, there are several factors that may affect the efficiency of UV irradiation. For example, the distance from the UV device, irradiation dose, what is the wavelength, and what was the exposure time, placement of the lamp and the edge, as well as room size and shape. So now there are two types of tests available for COVID-19. One is the viral test, and this test is for the current infection, where they use real-time RT-PCR technique, and this technique is a very sensitive, as name indicate, real-time RT-PCR technique. That means once you use this technique and follow the protocol, it will exactly identify in the sample that virus is present or not. And it is very sensitive. It detect as little as one virus particle in swab sample taken from inside the mouth or nose. Another technique for testing COVID-19 is an antibody test, and that is for the previous infection, and it measures the antibody response to virus in blood serum sample. It may not show the result if anyone has a current infection, because for making antibody after infection, it usually take 1 to 3 weeks. So let us talk about, is there any specific medicine available right now to treat COVID-19? And of course, there is no medicine available right now. And this is why the WHO is helping to enhance the research and development with several partners. However, there are several medicine which several countries are using, and they can solve this COVID-19, or they can treat the COVID-19 patient to some extent, but not 100%. The one famous medicines they are using is the remdesivir, and it is a broad spectrum antiviral medicine. The broad spectrum means this medicine is used for the several viral infection. However, this was authorized for emergency use for people with severe symptoms of COVID-19, and it was also tested in the case of disease caused by Ebola virus. However, this medicine was not able to treat Ebola virus 100%. So there is very interesting article published in Nature Communication this year, and they studied the efficiency of remdesivir if they will combine it with some other drug like lopinavir and ritonavir, and they found that this remdesivir is able to decrease the load of virus in body. So what finally they said, it has they showed the evidence of the potential for remdesivir to treat MERS coronavirus. Next drug is nafamostate and camoistate. So these are serine protease inhibitors. This drug is approved in Japan for use against inflammation in the human pancreas. There are several researches, and the researchers said that these two drugs have a similar effect in inhibiting SARS coronavirus 2. They found also in vitro to block the entry of SARS coronavirus 2 into cell was good in case of using these two drugs. However, there are some preprint study. They said that the efficiency of nafamostate was about 15 times more as compared to the chemostat. And because of the good result of these two drugs which Japanese doctors are using to treat the COVID-19, it is undergoing a phase 2 and a phase 3 clinical trial. Next one is the hydroxychloroquine, and we all know that this is the most arguable drug for the treatment of COVID-19. It is an anti-malarial drug which was used to treat the malaria. However, the early report indicated the fast improvement of some patient with severe symptoms of COVID-19. And it was initially authorized for emergency use in United States of America. However, it was not approved by the FDA for COVID-19 treatment. The reason why it was not approved was the side effect due to this hydroxychloroquine. The side effect includes the retinopathy, that is damage of the retina of the eye, cardiomyopathy, that is the problem in the heart. Some allergic reactions are the side effects of this hydroxychloroquine, and hypoglycemia, that is a decrease in the sugar level in blood. So next one is the favipiravir. This is the antiviral medicine. It was developed in Japan by Fujifilm Group, and it is mainly used to treat the influenza, because influenza in Japan is very common in the cold season. And there are number of studies which shows that this favipiravir was used previously for the disease caused by Ebola and Nipah virus. China and Russia also did a clinical trial of favipiravir, and they said that the drug was clearly effective. And Glenmark company, which is a pharmaceutical company in India, did a clinical trial on favipiravir, and their results came like 80% improvement of up to 80% in COVID-19 cases. So there is a good news recently. Last week, the Glenmark launches first oral favipiravir approved medication. This name is the FaviFlu for the treatment of COVID-19. So there are, now we can talk about what is the development in the vaccines to fight with the coronavirus. So still we don't have any vaccine, but there are several developers who are doing a clinical trial. So in the phase 2 and phase 3 clinical trial, the developer are from University of Melbourne, University of Oxford, and some other developer like Moderna is on the stage of trial phase, which is from United States of America. And several developer from Germany like BioNTech and Pfizer from USA and from China, they were in stage of 1 to 2 trial phase. So the development of vaccine for anyone, not only for coronavirus, any virus, it takes time, almost 1 year. And the reason is that the development of vaccine have several stages. So the stages are like that. They first have to do a preclinical test where they test the vaccine in animals to see the response of the vaccine. Then it come to the phase 1 where they give vaccine to some small number of people, and they check the immune response of the vaccine. In the phase 2, they give the vaccine to the people who have some special characteristic, for example, age or physical health problem. And phase 3, they finally give the medicine vaccine to the thousands of people, and they check for efficiency and safety. And phase 4 is a formal process, and after phase 4, they approve the medicine. So it is a long process and always take a longer time, about 1 year, to develop any vaccine for any viral infection. However, during the pandemic situation, a vaccine may receive an emergency use authorization before getting a formal green signal. So let us talk about a very interesting topic and the important theme of the conference, that is how this COVID-19 is affecting scientists or research and development worldwide. So very interesting survey I found in ResearchGate. ResearchGate, as you all of know, it is a very leading scientific network in the world. So they did a survey of how affected are scientists worldwide by COVID-19 pandemic. The survey was open on 18 March 2020. They asked researchers to share how COVID-19 is impacting their work. The survey was closed on 19 March after collecting the response from 3,000 people in the 24-hour window. However, this is the data of March 18 and 19 when India was not in the lockdown situation. So maybe the value can vary now if you will see the current situation. However, just I would like to discuss about what was the situation at that time. So if you will see, India and China, about 45% people agreed that their work was impacted by COVID-19. If you will see the situation in European countries, here also cases were the percentage of people varied from 26% to 60%. And in fact, if you will see the Canada and the United States and the Brazil, 50% of the people said that their work was impacted by this COVID-19 pandemic. What the value impressed me is that in Japan, if you will see 29.2%, and it is reasonable because although Japan was in lockdown situation in April and May, but postdoctoral researcher or professor was allowed to come to the laboratory for working. So there is we can say in Japan, in case of my university, there is no impact. Still, we during the lockdown also we were going to the lab and working and using all the facilities. However, it was closed for the students. So, although 82% people agreed that their work was impacted by coronavirus pandemic, I found based on the survey that researchers find alternative scientific activity to remain productive even they could not access their facility in the laboratory or institute. So what was the result? See, 67% people agreed to work from home. However, 45% or 43% people agreed that they are spending much more time on searching scientific literature or reading scientific literature during this pandemic. In fact, 43% people agreed that they are spending more time on writing scientific articles, submitting papers, and doing a peer review. And 68% people agreed that they are now spending much less time for attending research and a conference because offline conferences are generally closed because of this pandemic. And 43% people agreed that they are also spending more time to search a collaboration with other scientists. So where is the impact then? So to my understanding, the impact is on the field research. Suppose in a case of our study, we have to go to the field and then we have to collect the sample and come with the sample to the laboratory and analyze. However, Japan, it was not, institutes were not closed, but where the institutes were closed, the field research and data collection in the lab was a big problem. And even now this problem is continuing. Another effect is on the longitudinal research or observational based research. They are also facing a significant disruption in data collection. So I just linked COVID-19 with economy and then research funding, because we know because of this COVID-19, not only in India, the global economy outlook is highly uncertain. So what economists say, they say two important points. So if a second outbreak is avoided, they think that the global GDP almost it will regain its pre-crisis level by end of 2021. But if a second outbreak occurs, this global GDP will remain well short of pre-crisis level by end of 2021. So where it will give impact, maybe it will give impact in the future availability of research grants due to the slowdown in the economy, due to the reallocation of the funding based on the priority of research area. I will talk in the next slide about the priority of research area. However, because the offline conferences and the seminars were totally stopped, the quality, it can impact the quality of research, because from the offline seminar and the conferences, researcher generally exchange the idea on research, and it was a great benefit to the scientists. However, I feel that the short to medium term impact may be more as compared to the long term impact, and it can also vary from place to place. Because as I know, in India for several months the institutes are closed, so there is no teaching activities offline, only online is going on. However, research is not possible, performing laboratory experiment is not possible online. So it can vary from place to place. As I can see in our institute for researchers, there is no problem. People are going to the lab, and what experiment they want to do, they are doing, and getting the data. So as I talked in the previous slide about the research priority, I found one very interesting article about the research and the development blueprint of WHO. So the WHO activated the research and the development blueprint by looking to the Corona 2019 pandemic. And their objective was to speed up the diagnostic and the vaccine development for new coronavirus. They want improved coordination between scientists and the global health professionals. They also want fast track the research and the development process. And they want to develop a new norms and a standard based on the learning they have from this current global pandemic. So there was a meeting at the WHO Geneva headquarters on February 2020, and finally they specify the two goals. From that, the first one is the speed up innovative work to help prevent the spread of epidemic and facilitate care of those infected. And they also came with the goal support research priority that contribute to the global research platform, and in hope of learning from the current pandemic situation so that they can better prepare for the unexpected outbreak in the future. However, there is a several negative points of COVID-19. There is some positive things also, which is the funding opportunities on COVID-19. So I found there are several global funders offered funding opportunity to help a researcher to enhance their academic understanding and address the global pandemic. So I found almost, if I will count, it was more than 50, and I'm just showing here 3 call for proposal, which is depend on the collaboration of different countries with India. First one is the US mission to India. So they call for the proposal on the field to fight COVID-19 in India and globally. Another is the Omidyar Network India. They also call for funding to tackle the challenges due to COVID-19 situation and its economic impact. And the third one is the joint Australia and India research project again, which was actually offered by the two different projects. The one is the Australia India Strategic Research Fund Round 13 COVID-19, and another one is from Department of Industry, Science, Energy and Resources. So because I'm working in the atmospheric science, I was actually not willing to talk about my research field, as the theme of the conference is on COVID-19 and its impact. But when I see this satellite data and the satellite image of nitrogen dioxide over China, I could not control myself, and finally I decided to give, because this is showing a very interesting information. So you can see this is the satellite images of nitrogen dioxide over China, and this was actually detected by NASA and a European Space Agency pollution monitoring satellites. What is nitrogen dioxide? It is a gaseous pollutant which is coming from the automobile emission. So what China did at the same city in Wuhan, China has 3 phases. From January 1 to 20 is called as a Chinese before Lunar New Year or Chinese New Year. January 28 to February 9 is the New Year celebration, and February 10 to 15 is after the event. So during this time in 2019 and 2020, they compared the results. So in 2019, when there was no coronavirus, no such type of situation, you see the concentration of nitrogen dioxide was very high. Even it was very low during the New Year celebration, little bit high during before New Year, and very high after the event due to the more strong emission of nitrogen dioxide from its some important sources. However, in 2020, during the lockdown situation, because this COVID-19 started from Wuhan, and Wuhan was in lockdown situation from beginning of the January, you can see the concentration of nitrogen dioxide density, it decreased significantly. So what it indicates, the COVID-19 has helped the environment to clean, but we don't want COVID-19 like situation in future to clean the atmosphere. But what we can learn from this satellite image or from this result is that we can understand that totally we are responsible for the atmospheric pollution or global climate change. So what we can understand, we know very well what we did, what we reduced during this COVID-19 lockdown, and that we can continue. I know it will be not possible to do 100%, but our small contribution will clean the atmosphere in future and save us from the climate change. So this is my last slide. And as we know from this webinar, I discussed that there is no specific drug and there is no specific vaccines now for COVID-19. So we have only the option is the coronavirus prevention. So always use sanitizer and use a face masks. And as Professor KVR Murthy also said, stay in home if it is not important to go outside. So thank you very much. I hope this information is beneficial for all the panelists and for the participants. Thank you very much for your attention.
Thank you so much, sir. for your kind interest in the topic, as well as what exactly suits to the title of this webinar. You have given your presentation. Thank you so much, sir.
Thank you very much.
And our next speaker, Dr. S.J. Dobleji from RTM University, Nagpur. I would like to request Dr. Shubhra Tiwari to give a short description about Dr. S.J. Doble. Ma'am, please.
Thank you, sir. Our second speaker for today is Dr. S.J. Doble from Department of Physics, RTM, Nagpur University, India. He had his PhD degree on solid-state physics from Nagpur University and master's from Rani Durgavati University, Jabalpur, India. Dr. Doble is working in the field of luminescence. During his research career, he was involved in the synthesis and characterization of energy-saving LED materials, radiation isometry phosphorus, phototherapy phosphorus, water purification, and utilization of fly ash. He is editor, Luminescence, the Journal of Biological and Chemical Luminescence, John Wiley and Sons Limited publication, Vice President, Luminescence Society of India, Chairman, Luminescence Society of India, Vidarbha Chapter, Director Honorary, Inter-Institutional Computer Center, RTM, Nagpur University. Visiting Professor, Sejong University, South Korea. He has received India's Top Faculty Award for the year 2018 by Careers 360. Dr. Doble has published more than 757 research papers in international and national reviewed journals. In Google Scholar, he has 6,727 paper citation to his credit, and his H index is 33 and I10 index is 198. In Scopus, he has 5,288 citation and 556 research paper. His H index is 30, which is top in Maharashtra. To his credit goes 16 patents, 1 granted, 13 published, and 2 patents are filed. He is recipient of Fellow of Luminescence Society of India by LSI, Best Researcher Award 2016 by RTM, Nagpur University, Professor B.T. Deshmukh Award for the year 2016, Professor B.P. Chandra Research Award 2016, Outstanding Scientist Award 2015 by Venus International Foundation, Advanced Material Scientist Letter Awards 2011. He has received Best Research Paper Award for 38 research papers and is reviewer of 45 international and national journals. Sir has a teaching experience of 28 years and was principal for 5 years. He has guided 53 students for PhD degree. His abroad visits include countries like Italy, Egypt, Greece, Australia, China, South Africa, South Korea, Sweden, Japan, Malaysia, Hong Kong, and England for research, education, and conferences. He has successfully completed 6 research projects, which amounts to more than 1 crore 50 lakh rupees. He also has different research projects, including of UGC, under his belt. Sir is a co-author of 32 books, chapters, 3 of which are international level, published by Elsevier, Springer Science, CRC Press, Taylor and Francis Group, Transtech Publication, Nova Science, Lombard Academic Publishing. So presenting before you, the man himself, Dr. Sanjay J. Doble. He is going to speak on the topic phosphors for ink and their application. Sir, please.
Sir, your system is unmuted, sir.
Okay. Thank you,
Yes, sir.
madam, for your kind introductions. And I'm very much thankful to Saruja Kaur madam to invite me, and Vikas Dubey is my very close friend. I'm the last speaker of this your conference, and I will try to introduce some of the point on this topic. So my topic is the phosphor for ink and their applications. So synthesis of novel red luminescence hydrobid europium thiol pen nanophosphor complex and luminescence hybrid thiol nanophosphor complex was used to develop luminescence ink for the anti-counterfeiting application. This is the work recently done by Ford and Safe, and this is the published in the Journal of Material Structure. So nowadays, is this the very important to the security ink, fingerprint, and all other application. So I'm just consider all the research work discussed with the student. So it is very good topic open for the research. So great attention has been paid to synthesize the novel hybrid thiophen nanophosphor, and this material is recently reported. So the property, or due to its property like structure, morphology, and optical character were investigated, and it may be the applicable as fluorescence sensor for highly sensitive detection and latent fingerprint and anti-counterfeiting. So this material is the important in the two causes. One is the fingerprint, and second is the anti-counterfeiting. So 10 image of the ternary hybrid in this phosphor, the complex was clear aggregate hybrid morphology between the sheet and rod shape, and their crystal size very nano domain. This is a very important part. It is the crystal size is very the nano domain. A pure red emission of the europium 3+ nanophosphor, always in the very sharp band around to the 600 nanometer, and complex with the long lifetime value was obtained under the humblest UV A, B, and C excitation. So optimization of the photoluminescence of the nanophosphor complex effectively developed as a novel sensitive material for the visualization of the latent fingerprints and from the various forensic relevant material. So nowadays the police use these are investigation agency use this type of some of the material, but this party is not known what is the characteristic of the which material used. So it is also possible to the awareness of this material, and just some of the drawback by the police department, you can according to develop your material by the luminescence society, and then it is very useful for the investigation for this purpose. So this is the very systematically present of the synthesis. One is the europium nitrate, and this is the frame, and then the thiol is here, and then after 8 hours you can find out that this type of material, and after the UV excitation it is observed in the red colors due to the U3+ emission due to the 5D027F2 transition, and then it is the just the where the fingerprints just put here, and then just the fingerprint impressed on the glass, and then it is just you can wash. This is the spread the powder, and you can excite it by the 365 nanometer. It is called the near UV excitation. So this is the red emission is possible, and just you can find out between these two, it is so many points they are observed, and these points are very useful for the total presentation of this one. Just you can see here the number of lines easily observed. Again, the trivalent lanthanide ions such as the europium show a rather weak photoluminescence in solution or in solid state. This requires the use of the organic chromophore of the antenna, and therefore as sensitizer of the energy transfer in order to indirectly excite the metal center. Consequently, the lanthanum third complexes had characteristic of the luminescence property and gave the sharp and intense emission line upon the ultraviolet light irradiation. So just you can see here that this is the lanthanum, and just you can excite it by the near UV excitation. Therefore, it is the emission in the you can observe, and this is the easily indicate with help of the energy transfer mechanism. So this is the rod type of the structure and some of the sheet type of the structure, but it is the width in terms of the nanoscale. So this is the morphology of this the prepared material. So just you can observe, you can excite it by the 350 nanometer, 250 nanometer. This is the mercury excitation. So just this color, and here the two band observed here. One is the 5D0 to 7F1, second 5D0 to 7F2 transition, and this is a narrow band. It is a very exactly red color of the spectrum, but one, it is again weak band observed at the 665 nanometer, but this is the far away. And eye sensitivity, it is a decreasing to here. So this peak is not useful much more for the taking the fingerprints of this one. But this peak is very important. But just when excited by the 352 nanometer is the near UV excitation, and intensity is slightly near, but this peak is very high. So you can take the photograph and you can analysis of this. So this peak, it is not observed by the naked eyes, but you can take the photograph. So this is the lines are very clear. So this band used for the naked eyes, and this band useful for the photograph, and you can analysis of this one. So this is a very important material for the fingerprint application, and this is the CI diagram. Just you can consider this is the in part of the array. So this is the very useful, and just you can excited by the UV irradiation by the different time. So up to the 90 minute also. So it is not much more in the changes. It is a little bit changes, and this you can consider this is the UV illumination for the up to the 90 minute. So this is the UV visible absorption spectra are the same. Or three number of peaks are same observed intensity. It is also same observed. Nature is not changed, but just you can. This powder sprayed on the thumbprint on the left. So just you can observe your fingerprint is clearly. Just you can observe on the glass sheet is very clear. Just you can see. So our nanoparticle size is less than to the distance between these two lines on our fingerprint. In that case, only you can observe what is the structure of this fingerprint, and you can match with the number of people just in this order, and you can identify who is the person, and this is the fingerprint. Again, in the curvature glass also, just in the implanted plastic page also, and this is the plastic page here also is very clear. Just you can see here, black paper there is no problem, aluminum foil also no problem, and fabric work. So if sometime you can use for the forensic application, so out of this some of the things are possible, and you can just find out that this fingerprint, and it is very important our the phosphor, and you can excite it by the near UV excitation 360 nanometer. It is a like irradiation. So just is that this fingerprint are just you can find out is very clear. So then according to this, your material is a very best material. Our emission is also very good in under the near UV excitation. Then you can find out the very good lines, and this is the very useful for the fingerprint. So number of new researchers develop the good material. You can find a good characterization, match the XRD, and just you can check the fingerprint on the different surface, and you can identify which material is the best. So this is the contribution for the luminescence society or physics people or chemistry people to or the police department. So it is very essential our contribution for this purpose. Again, just you can find the level 1 arc, double loop, worth, and left loop. Then everyone small part you can also consider. Then it is the optical image fingerprint is detection is possible with help of the European 3+ nanophosphor, and European 3+. It is a very narrow band around to the 613 to 450 nano nearby. So then this is a very rare emission due to the 5D0 to 7F2 transition, and this transition is very useful. But in this source, one peak is observed about the 670 nanometer. This is the not eye sensitivity decrease the 40 times, but in the camera you can easily possible to catch. Then photograph again is the very sharp. So this is the anti-counterfeit labels. This is not observed, but this is our material. You can excited by the UV light. So this is the clear picture is observed. So this is also useful for the secret ink also. So secret ink useful for the defense purpose or a different type of the security purpose. So this same material, it is also possible in the different application. So synthesis of the novel red luminescence, hybrid thiophenol nanophosphor complex, luminescence hybrid thiophenol nanophosphor complex was applied to the developed patent and fingerprints showing that is excellent property for this application. The obtained image were of high contrast and without background. Luminescence from different substance. So luminescence hybrid thiol pen nanophosphor complex was used to develop luminescence ink and for anti-counterfeiting application. So this is a very good application and good contribution for the physics or chemistry people. Those are working in the field of the luminescence. So this is the Luminescence Society is good contribution for this purpose. Next material I've just discussed as a synthesis of the phosphor ink. So in this one, to counterfeiting and copy security documents are significant challenges for the country, and that extensive cost to update the security and authentication sign of the documents. So using the novel anti-counterfeiting material and especially polymeric anti-counterfeiting ink with complex and high security identification technologies could be the best solution for such issue. This work is recently reported by the Amin Abdolani et al. So this is a very good is the recent work already. So this is the eco-friendly multicolor photoluminescence thing. So this is eco-friendly is what is very important in the Luminescence Society of India. You can develop the any type of the ink or any type of the material, and this is the protect the environment, that this is the material is good. Otherwise, this material is create much more problem. So this is the eco-friendly. So photo detection of originality and authentication of the security document such as the money, passport, banknote, and nation card have been a significant challenges in recent decades. Using of the advanced optical system could remarkably reduce the copy of and counterfeiting of such national and international documents. Now, eco-friendly multicolor photoluminescence ink were developed for the information of this material, but this is the optical characteristic of this material. So this is the very useful for the photoluminescence characteristic, and this is the observed in the sometime in the blue color and in the red color as well as to the orange and orange red emission nearby. So some of the latex with the higher fluorescence emission were formulated to white water-based ink and then loaded to stamp with the different mark of the printing of the quick response code, barcode, fingerprint, and other mark on the cellulosic document. All the printed marks display ultra bright blue, red, and orange fluorescence emission upon the UV irradiation, which have potential application in the this is very useful in only in terms of the security. So security is possible with help of the optical characterization of this material. So just you can see the quick response of this material just in the different color, and then you can just see here you can observe the photosensitive originality of the counterfeiting and confidential cellulosic documents, and is used for the security inks. So the important of this material, it is the only anti-counterfeiting material result from its potential simultaneously display photochromism colorizations. So and fluorescence emission in response to the UV light irradiation by means of the fast isomerization reaction between the discolored non-fluorescent and non-fluorocyproform and colored fluorescence and polar macroscreen from, and it is the just you can denote it. So you have what is the preparation of this type of the ink? Preparation of this material is very simple. Just you can use the only the content of this one SPOH and SPOH and COH was carried out by the mixing of the solution of the PEG and glycerol in the 4 ml of the ethanol with 15 ml of the fluorescent latex sample and evident condition under the stirring for the 24 hours. So this is the use, and just I can spread on the pages so you can easily find out this one. So after the completion of the required mixing time, the homogeneous colloidal ink could be used for the writing by the pen, fingerprints, and print marking by the stamp for the labeling of the security document. Just you can see here the illumination of the free illumination polymerization. So just here is the NSPOH, and after that you can mix it, and then so it is the spread, and just you can observe here the systematic illustration for the synthesis of the photochromic of and fluorescent latex nanoparticle based on the spring parent and columnary derivatives. So this derivative is very important for this purpose. And here is our material shows the ray emission. This is the particle analyzer. So this is the depending on the size, 980 nanometer, 810 nanometer. So only for the here, the zeta potential is the same. This PMA, HMA is the same. This is the change. PMM is fixed. HMA is GMA, and you can change that corresponding. It is the particle size distribution. You can easily observe to here, and it's shown this picture. Now, the same image of the functionalize the polymer nanophosphor with the adjacent function group. So you can change this function group. This particle size is the drastically changes, and you can find out the 1 micron size, and then this size, just you can see here the equal size of this particle are observed. Here also the same thing here. So depending on the A, B, C, D's indicate here. So then this is the very good chemistry is observed in the synthesis of this material, and this is the bonding to each other. Just you can see here is bonding to each other. So this is the very nice presentations of this material. So photochromic and fluorescence properties of this material. Just you can see here before UV irradiation, under the UV irradiation, and after UV irradiation. So before UV irradiation, there is no any light emission. It is a very background light, but under UV irradiation, you can show this is a very bright light. So you can use as a security ink, and then after UV irradiation, again come back in the same position. You can check this one and this one in the same condition. That means only under the UV irradiation, this emit the color, and that corresponding you can take the photograph and you can find out what is the confidential matter in this case. So again, same image of the impression, the cellulosic paper, just the particle size is the completely changes with respect to this PS and GMA, and as well PMM and GMA is the combination, and that corresponding is the particle size changes. But it's a beautiful result in the photoluminescence. Just you can see here, this peak is the 650 is very strong, but here just you can check again. Here is the 380 nanometer, it is the excitations. Here it is also excitation, but in that case, this is the emission peak is very strong, and therefore this is the possible. So just the SPO based on the PMMA, excited 370 nanometer, it is the figure number A. So you can observe this is the material. Here is the 370 nanometer excitation. Just peak position is the change, observed good, and here PS, DM, EMA, it is maximum intensity. In that third case, it's the excited by the 320 nanometer. So here is this peak in the near to UV. 410 is the near to UV. Only for this the 430 peak. But again, if you can change this one, that excitation position is the changes, but this peak position is the near to. But these two results are very important near to UV region. So again, just you can observe the different sign. You can indicate barcode, thumbprint, and like again some picture under this light is very useful, possible. So the photoluminescent latex, the nanoparticle formulated to water-based polymer ink, were the loaded to the stamp with a different pattern of security marking and cellulosic the paper, the printed quick response code, barcode, fingerprint, and other mark display ultra bright red and blue fluorescence emission under the ultraviolet light, which could act as an optical sensor for the photosensitized originality and counterfeiting of the security documents. So this is the very good result is observed by this one. The strategy of the development in the study can industrialization, particularly this type of the material you can prepare, and you under the UV light you can use in the different type of the application. So this is the multicolor emission you can also observe in this material. Just you can change the composition, and then you can easily find out this picture. The structural and surface morphology of the investigation have been carried out by X-ray diffraction and scanning electron microscope analysis respectively, and the mechanism involved the up conversion emission also we identify the decay curve analysis. So now again I'm come back to the next result presented by the Abhishek Kumar Soni and Vinith Kumar Roy in 2014. And why selected? This is a very good result. BHZN LA2O5U. So nowadays it is so many material, but it is very difficult to the stability of this material. It is a thermal stability of this material. So I'm select this particular material is the BHZN La2O5. Here the lanthanum. Lanthanum is the rare earth base. It is in the LA used in the host material. The cost is very little bit high as compared to the normal one. But Holonium and YB is show the good characteristics. Synthesis XRD same FTR, PLDK and specific characterization. So this material is prepared by the chemical precipitation method, only by the barium carbonate, zinc oxide, lanthanum oxide, HO2 and YbO3 with the 99.9% purity were taken in the starting raw material. And that this is the first you can prepare the barium carbonate to barium nitrate, lanthanum to lanthanum nitrate, and zinc oxide to zinc nitrate, and after that barium nitrate, lanthanum nitrate, and zinc nitrate is combinedly prepare this material BHZN La2O3, and that this is the precipitation is very observed, very good observed, and the composition of the precursor. So it is very important. What is the value of the X? So one number of type of the combination we are find out, and base combination presented to here result. The stoichiometric amount of the precursor material have been reacted with the HNO3 acid and heated up to 80 degrees centigrade only. So this is the temperature is very less, so you can easily maintain your laboratory. It is not required the good high temperature furnace. The prepared nitrate of the starting material were mixed together, and precipitation was obtained with the addition of the strong base of into the nitrate mixture, and then you can dry it at the 500 degrees centigrade. The 500 degrees centigrade, the common furnace is available 2 to 5 minutes around, and then you can quench only for the 3 hours 800 degrees centigrade. So this is the very one by one step, and you can fire at 800 degrees centigrade. So material show the good characteristic. It is the XRD pattern is the well match with the standard one, and this FTR it is also shows the sort of metal and oxygen bond, CO3 bond, CO bond, and OH bond, and this is the again OH bond. So this all these points is indicate in the FTR one is show the good characteristic, and this is the same image of this material. Show the some is not the regular shape, but irregular shape, but just sometimes the rod type of the structure also, and algomerism is possible due to the paper by the wet chemical method. So this is show that here the particular concentration is maximum observed at this point, and just you can see here the different type of the peak is here. But again, holonium is also the maximum concentration in this point. And holonium you can fix, and YB you can vary. So with the holonium is constant and YB is vary. So this is the concentration. So this is the way you can identify which one is the best common concentration in this material. And then here the excited by the 980 nanometer, that means this is the up conversion material. So emission is observed the 550, the green region due to the HO and YB, due to 5S2 and 5I8 transition, and this is the very good green phosphor useful for the security ink. This is the only energy level diagram, and this is the observed in the green region of the spectrum. This is the decay time in the very less. And then just here you mention the laser, but you cannot see any matter, but you can excite it under the 980 nanometer excitation. So this is the up conversion. You can observe this is the green emission of this words. So you can any matter is the security point of view. In the common light is not the same, but under the 980 lasers or 980 excitation, you can see what is the matter. So therefore, this is useful for the security ink for the different purpose, and mainly same purpose is that you can government document and also useful, very useful for the defense purpose also. So any luminescence people work in this field, so it is contributed for the country. If it is contributed in the defense purpose, so you are self-dependent. You are not dependent to the other country. This is the main part. So if you have to do the good work and develop the good ink, so this is the self-dependent for the our defense purpose, our government document. So this is a very good contribution by this material. So I'm very happy to very good result. Another, this is the Bipin Kumar Gupta. Bipin Gupta from the National Physical Laboratory is very good work in the field of the luminescence. He developed a very good material, long-lasting material, as well as the security ink. So this research published in the Journal of Material Chemistry 6, And then it is the result. Just you can observe two color are red and green. Red is the 611 nanometer and the green is the 532 nanometer for this material. The advanced security feature of the ink comes from the change of the pigment color. Currently, the currency note and display only the single color with the emission of the wavelength. In the evident light, the ink showcase white color. When the exposed to the ultraviolet light is the 254 nanometer, it changes the color to red when is the UV source is switched off. So this is the main part. You can switch off, then you can observe, and it turned to green. He added. So color can be seen through the through the naked eyes. So according to the researcher, the technique of the dual emission luminescence pigment for the security purpose is the first of its kind and never used of the for printing of the notes and core confidential documents. This is the research by the Dr. Bipin Kumar Gupta from the National Physical Laboratory. He is a very sincere researcher. So counterfeiting of the color notes, currency notes, according to the Reserve Bank of India, and it is found on the some study on the notes, Indian rupees, and according to the report, the duplication of the new design of rupees 500, but you can this type of the work are done on the Indian rupees. First, you can take the permission of the bank. Without permission of the bank, you will not allow this note useful for this purpose. It is not allowed. You can spread the ink on this note. Note, it is the Indian currency, Indian property. So you have not any right to disturb this note. But proper permission of the bank, it is possible for this purpose, or you can discuss with the bank people and they are find out what is the solution for this purpose. The currency note are embedded with about the 10 security feature, including the 3-dimensional watermark, micro lettering, and security threads and colors sheet pattern. So this is the dual main task of the terms was to select the compound. Compound is very important. The formation of the color of the excitation of the wavelength for the production of the luminescence and pigment and two chemical compound, sodium yttrium fluoride, europium dope, and strontium aluminum eliminate with the europium dysprosium were synthesized to emit red and green color respectively. The fluorescence property through the sodium yttrium fluoride, while the phosphorus it's by the compounds strontium and illuminate. The NPL researcher used to the hydrothermal synthesis method to get the red color. So this is a very good result for the, and it is also useful for the at high color temperature also. So this is the result also checked at up to the 400 degrees centigrade, and then it is very full. I'm not going in the detail. So, but for the feasibility of the test of the ink, the image was printed on a non-fluorescence whiteboard prep paper using the standard screen printing technique. So the results showcase the emission of the red and green color under the 254 nanometer UV excitation when the source was turned on and off. So properties and application of this material is to analyze the stability of the ink. The researcher conducted the chemical test with the various bleaching agent like soap solution, ethanol alcohol, ethyl alcohol, and acetone. So this is the condition like the humid atmosphere, hot and cold. So all these conditions you can check this material and which one is the best possibility you can report, and that correspondingly it is useful for the good application. So this is the under 250 nanometer, and under the 250 nanometer UV light is off, and this is the UV light is switch on. So one color under the UV light, you can UV lamp is the switch off, that it is the green color. So this is the quality of this material, and this is the work done in India. So I'm very happy, and thanks to Bipin Kumar Gupta for your good contribution in the field of the luminescence. So this is the hydrothermal method is very well known. I'm not going in the detail. This is a commonly available this paper you can see, and this is the very useful material. Now in the lockdown, Lucknow Shiv Nadar University also reported a very good material. Lucknow Shiv Nadar University. So this research team has created a unique security ink, and this ink is not feasible under the normal range condition, but the ink data can be seen when the placed under the ultraviolet light source. So research team comprise this material. So particular type of the material is developed by this person, and this material is environmental friendly, low in toxicity, and not harmful for this common use. So this develop this ink. So this ink, it is just is the in the detail I'm just explaining. This security ink phenomenon incorporated the element of the both fluorescence and phosphorus. So fluorescence and phosphorus mean it is a very short decay and it is a long decay. When the UV light is switched on, the characters become visible under the UV light and in the white background due to the involvement of the both fluorescence and phosphorus. So as soon as the light is switched off, the character remain visible in a different color only for a fraction of the second. So this is the fraction of the second. You can see this one due to the phosphorus. The ink by virtue of its chemical composition can alter its emission abilities under the specific light condition, thereby giving in the ability to provide additional layer of the security to enhance its anti-counterfeit capability. So this is the main part. That's it can be provided a higher degree of safety and authenticity to a host of government documents, just like to the stamp paper, passport, checks, etc., currency, private classified documents, as well as to the night vision product used by the private and government agencies. So this part is very important. The luminescence in night vision product, it is also possible. So inkjet print and all these documents are possible in the full color micro light emitting diode display. And macro light emitting diode have been considered as the excellent candidate for the next generation of the display technology because of their promising optical property, outstanding power efficiency, fast response time, and high reliability. The macro LED display based on the individual red, green, blue primary chips suffer from the several issues, and then you can find out that this one. So all my new young researcher is, if you can work in this type of the one, so it is possible good output from your end to the society, and your academic record also good. You can publish the very good high impact factor paper, as well as you can, on the basis of, you can get the postdoc fellowship in the abroad. So you can find the who are working the same topic. You can contact this type of the person, and it is possible the very good work. So this is the you can say the blue macro LED with the inkjet print quantum dot color conversion is the high resolution. So all these results are very important, and just the rapid progress of the quantum dot base. I'm just a little bit to give the idea. So my young researcher minds is going to start and think on this one and develop the good output by the Luminescence Society of India nearby in the future. So this is a very good security ink purpose for the different application, mainly the defense and security purpose. So I am very interested in this topic. That's why I'm selected. A number of time I'm working discuss with the LED material, thermal emission dosimetry. But this topic is every time is the miss my end, but it is very useful for my student. So that's why I'm selecting this topic. So I think this is enough for my end. So latest progress made in the inkjet print quantum dot CCF and their potential application for the full color macro LEDs. So these are my all international collaborator. This is Rick Polman. This is Dr. Aro from Malaysia, Professor Swart from America, Pandey sir from the USA. This is Break. This is the Martha, and this is my collaborator from England, Alexander, and all this. And this is again Dr. Balakrishnan from Malaysia. This is from China. This is from England. So if your work is good, so many people is work with you also. And if you can work with so many people, then your student directly placed in the good place as a postdoc fellowship. And so, and as a teacher, as a researcher, I'm always try to our student always shift in the good place. So this is my request to the all young student. You can select the very good topic, work hard, and you can get the good job in the form of the postdoc and other one. So my lab is open for the researcher collaboration. I hold only for the for this reason is a very hardworking and better understanding. If you have the hardworking capacity, you are better understanding, you can work any lab and you can easily show the very good output. So thank you, Saluja Madam and Vikas Dubey. Saluja Madam is always ordered to me, Doble sir, you join this one, but I'm the last batsman of this conference. There is no question. So, and Vikas Dubey sir, this is the okay sir, aapko aana hai. That's okay, boss, aata ho. So that this one. So both are my very good research colleague, and I'm very happy by these two persons. I'm developed the research group in the nearby Bhilai and Raipur also. So email, this is my email ID at readymail.com, gmail.com also, and the same. And this is my mobile number. So thank you all this person. Thank you very much.
Thank you so much, sir. It was an immense pleasure to have you in this session of the webinar series. Thank you once again for your valuable session, sir. Now I would like to invite Dr. Jagdeep Saluja ma'am to proceed ahead with a valedictory speech. Ma'am, please.
Thank you, sir. Good evening, Doble sir.
Good evening, ma'am.
You are not the last batsman, sir. You are opener.
No. Okay, I'm just saying that I'm just Murthy sir always just start opening batsman. I'm the okay. Close it. So big man is on both sides.
Thank you. Thank you. Very nice lecture delivered by you, sir. We always learn from you, sir. Now, at last, for a valedictory speech, I welcome all the eminent speakers, all the participants in the valedictory function of International Webinar Series on Worldwide Effect of COVID on Research and Development. Today is the concluding day of this 3 days webinar series. It is our great pleasure that we have learned a lot from our eminent speakers, Professor Polman Dirk from Belgium, Dr. KVR Murthy from Baroda, Dr. Sudipta Som from Taiwan, Madam Martha from Poland, Professor Chari from Rowan University, New Jersey, USA, and Dr. Dhananjay from Japan, and our eminent speaker, Dr. Sanjay Doble from RTM Nagpur University, Nagpur. I, on the behalf of organizing institutes, Government VYT PG Autonomous College Durg, BIT Raipur, and Luminescence Society of India, thankful to all the speakers and all the participants. I hope all the participants learned and update their knowledge by this webinar series. We are honored by the time given by such eminent speakers from other countries and from India also. You all make our webinar success, and I am also grateful to all the participants. Nearly 750 persons registered for this webinar. At last, but not the least, I am extremely thankful to Dr. Ajay Singh, Professor Chemistry. Without his support, this event could not be possible. And I am very much thankful to Dr. S.D. Deshmukh, Professor Geology, for his valuable technical guidance and support. And finally, thank to one and all. Thank you very much.
Thank you so much, ma'am, for your valedictory speech in this international webinar. Now I would like to call upon Dr. Vikas Dubey ji, the man behind the show, to please proceed for the conclusion session of the international webinar series. So
Thank you
please.
very much, Khwaja sir. Now, after 3 days marathon, we are on valedictory session. I am very thankful to all speakers. Our 3-day program. First is Professor Dirk Polman from Belgium. He has presented a very nice and useful lecture related to phosphorus traps formation, virus up to the dosimetric application of recent luminescence materials. After that, Professor KVR Murthy, he is a president of Luminescence Society of India and presently working as a professor in MS University, Baroda. He is very nicely presented the killing of coronavirus through UV light. He is nicely presented the UV 254 nm wavelength light, that is the UVC, for the protection of goods with the help of UV ray detection techniques. After that, very informative presentation by Sudipta Som from Taiwan. He is working in white light emitting diode, that is phosphor controlled white light emitting diode, and he is nicely presented this correlated color temperature, CRI, that is related to color rendering index, and how we can form the tri-band phosphors and tetra-band phosphors for the future generation of light sources. After that, the second day, Professor Chari is represented very informative session related to drug delivery and application of nanotechnology, which is beneficial for human and social cause. After that, a very beautiful lecture given by Dr. Martha from Poland related to introductory of aluminium anodic oxide for various applications of energy efficient solar cell. Now, today, my friend Dr. Dhananjay Deshmukh, very informative and very nice lecture related to what is COVID-19, how we can protect from the COVID-19, and till date, no drug will be discovered for COVID-19. But in India, Patanjali, sir, Deshmukh sir, Patanjali challenge that Coronil is recover COVID disease in within 7 days.
Okay.
Last but not least, my guru, my friend, Professor S.J. Dhoble from RTM University Nagpur, he is nicely presented ink phosphors for forensic applications, related fingerprint detection, how we can use the security ink, as well as different forensic applications of phosphors. Thank you very much, sir. Now,
our university name is the RTM Nagpur University.
Yes, sir. It's a RTM Nagpur University, sir. And I'm very thankful all organizers, including our government VYT PG Autonomous College Durg, principal government VYT PG Autonomous College Durg, HOD Physics, all faculty members, as well as BIT BIT Trust and BIT Management, and our principal, Dr. T. Ramarao sir, for providing opportunity to us to organize this event. Also very thankful to Dr. KVR Murthy sir for giving opportunity to organize such webinar related to challenges in research and development during the lockdown situation. Thank you very much, sir, and very thankful to all participants for such event, and Mohammad Khwaja sir for the nice conduction of this event, and very thankful to Khwaja sir and all the organizers, convener, co-convener, organizing secretary.
1 minute. I congratulate Vikas Dubey. In a year, he was organized offline and online 2 international conferences.
Sir. Thank you,
for
sir.
the area. So great job done by you also.
Sir. Thank you, sir. Thank you very much to all. Thanks, all the participants. Thank you.
Thank you, Vikas Dubey, sir.
Sir.
Really, it was a forever compliment by Dr. Sanjay Dhobleji that the online offline conference as well as webinar has been conducted as well as hosted successfully in collaboration with Bhila Institute of Technology, Raipur. Now, I would like to invite Dr. Neha ma'am to proceed with vote of thanks for the end of the session. Ma'am, please.
Thank you, sir. Good evening, everyone. It has been very fascinating and very engaging 3 days. It's just not a person. There is a huge team behind it. First of all, I would like to thank our speaker that they shared their knowledge and idea of different fields with us. Very innovative and very informative talk delivered by them. So thank you so much. They given us precious time. And our speakers, thank you so much. Dr. Dale Coleman, Dr. KVR Murthy, Dr. Sanjay Dhoble, Dr. Martha, Dr. Sudipta Som, Dr. Ramanujachari, Dr. Dhananjay Deshmukh, and so on. And my heartily thankful, I am very much thankful to participants for engaging the session. The kind of dedication these shown is exceptionally wonderful. Now, I would like to thank all the organizations who supported us. Now, I would like to thank Dr. R.N. Singh, Principal Government VYTP College Durg, Department of Physics, the HOD of Department of Physics, Dr. Purna Bose, and Dr. R.S. Singh, Dr. Anita Shukla, Dr. Abhishek Mishra, and Siteshwari Chandrakar. We are very grateful to Dr. T. Ramarao, Principal Bhilai Institute of Technology, Raipur, for their kind support and motivation, and all the faculties of VIT, Dr. R.K. Mishra sir, Dr. Amit Thakur sir, Professor Manish Mishra, Professor Abhilash Trivedi, especially Khwaja sir, and Dr. Ratnesh Tiwari. I am also very much thankful with the bottom of my heart to Dr. KVR Murthy, President, Luminescence Society of India. Last but not the least, I would like to thank Dr. Jagjit Kaur Saluja and Dr. Vikas Dubey, who initiated the idea of webinar and organized such a wonderful webinar. And without them, this webinar could not be possible. Also, Dr. Ajay Singh sir, Department of Physics, Dr. Deshmukh sir, Department of Geology, Science College Durg, Dr. H.P. Saluja and Himesh Saluja. So thank you so much to all of us. Thank you so much.
Thank you so much, ma'am, for your kind vote of thanks speech in the end of the session. Once again, the names, whatever taken by Dr. Neha ma'am, are completely the persons behind this successful completion of the webinar. So with these words, I once again congratulate all the panelists, all the speakers, all the participants for a successful involvement and contribution towards this worldwide effect on COVID-19 of research and development webinar organized under the banner of Government VYT PG Autonomous College Durg as well as Bhilai Institute of Technology Raipur. Thank you one and all. Participants could find the feedback form.
Khwaja sir.
Participants could find the feedback form in the chat
Khwaja
box. Sir, please.
Sir, interrupt करूंगा.
Sir.
सारे organizers को sir बुला लीजिए please.
I request all the organizers of this international webinar series to please come on to the cam as well as on the mic. I request all the organizing members without whom the show cannot be started and ended. So I request each and every member, those who have been involved for the successful organizing of the international webinar, to come onto the cam and onto the mic.
Hello, good evening to all. Thank you so much, all the participants, all the guests who have joined here. And thank you, Vikas sir, for giving the opportunity and organizing this wonderful webinar. And also Neha ma'am, Saluja ma'am, and also Khwaja sir for your esteemed insights. A very great presentation was there. So definitely we'll look out, we are looking in future, we'll again organize the same in same manner. So thank you so much one and all present here. Thank you so much.
He was one of the conveners of the program, Professor Amit Thakurji from BIT Raipur. So I'd like to listen the compliments of the remaining organizing team members.
Dr. Ratnesh Tiwari.
Ratnesh sir. Dr.
Yes.
Ratnesh Tiwari.
Yes,
sir.
yes, yes. Yes. Visible kya? Are you hear my sound?
Sir.
Yes, yes, yes.
Yes, sir.
Yes, yes.
Good evening, everyone. I would like to thank you all to organize such an international webinar. Greatly, जैसा दोबले sir ने बोला, it is very thankful to Dr. Vikas Dubey sir. He organized such a good conference as well as good webinar in a short time. Also, I am thankful to all organizer, all participants, especially guest speakers in different countries, those who have provided their valuable time in this COVID-19 lockdown duration. And I am very thankful to, on the bottom of my heart, to all organizer and all participants, Khwaja sir, all team members. Without our team, it cannot be possible. So this is the beginning of our journey. Please we continue with these things. Thank you, Neha ma'am, all participants and all. Thank you very much.
Thank you, Dr. Ratnesh Tiwari ji. We would also like to listen more comments from our organizing team members. Please do come onto the cam and also onto the mic. This is a precious moment for all of us that we have been hosted the complete 3-day session with an eminent speakers.
Abhishek Mishra sir.
Sir Abhishek Mishra sir.
Hello. Good evening to all of you. Hello. I am audible.
Sir, good evening, sir.
Good evening,
Yes,
sir.
audible.
Thank you for your such nice. Hello.
Yes, sir, audible, sir.
उसको नहीं आ रही है क्या आवाज? अभिषेक, तुम्हारी आवाज आ रही है, बोलो। नहीं बोल पा रहा, वो म्यूट हो गया। कहाँ से? यहाँ से म्यूट हो गया क्या? तू आ गया बीच में, ये देखना।
नहीं, यहाँ से
Hello, Siteshwari madam.
कहाँ है सिद्धेश्वरी? देख तो विकास, आना पड़ेगा।
Siteshwari ma'am, you are requested
Hello.
to unmute the mic.
Yes, sir.
Hello. Yeah,
Thank
ma'am.
you,
Now
sir.
it's audible.
Yes, sir. Thank you to all of you, and especially thank to Dr. Jagjit Kaur Saluja ma'am and Dr. Vikas Dubey to organizing such a good international webinar. And I am also thankful to very much Khwaja sir and Neha Dubey ma'am, Dr. Poona Bose ma'am, and all the teams and faculty members of BYT College Durg and BIT Raipur. Thank you to all of you, and I'm also thank to participant who giving time. Thank you very much to all of you.
Abhishek.
Thank you, ma'am.
Yes, madam.
Hello, everybody. I am specially thankful to BIT Raipur and Luminescence Society, President of Luminescence Society, Dr. KVR Murthy, and special thanks to Dr. Vikas Dubey, with the help of whom we could organize such a nice worldwide COVID-19 seminar and jointly with these two societies, that is BIT Raipur and Luminescence Society of India, Dr. KR, President of KVR Murthy, and special thanks to Dr. Vikas Dubey and our faculty member, Dr. Jagjit Kaur Saluja, with the help of whom we could have organized such a nice seminar. Also, I am thankful to the speakers, eminent speakers from worldwide, that is from Belgium, Dr. Paul Mann, Dr. KVR Murthy from India, MS University, Baroda, Sudipto Som from Taiwan,
Dr. Chari from New Jersey, USA, and Madam Martha from Poland, Dr. Dhananjay Deshmukh from Japan, and at the end, Dr. Dhoble from MS University, Baroda, Nagpur. So, okay. Again, I am thankful to our principal, Dr. R.N. Singh, who allowed us to join this, to organize this webinar. So thank you very much.
Thank you.
Okay. Okay.
Anita, madam. Anita, video on रखो Anita अपना. Anita Shukla, madam.
Anita Shukla, ma'am. Anita Shukla, ma'am, is yearly requested to come on to the cam as well as mic.
Unmute your mic.
हेलो
आ रही आवाज आ रही वीडियो
हाँ
नहीं
एक मिनट
अनिता वीडियो नहीं आ रहा तुम्हारा
जी जी मैं देख रही हूँ हेलो
हाँ आवाज आ रही है
जी हेलो गुड मॉर्निंग गुड इवनिंग एवरीवन
मैम एंड हैप्पी बर्थडे मैम
Thank you.
Many happy returns of the day.
Thank you so much, sir. This is very informative and useful webinar organized by our college and BIT Raipur with eminent speakers. And we should always remember for in this lockdown period, we are very much informative, knowledgeable in this session. Thank you to all. Thank you all, organizing committee and all participants. Thank you so much, sir.
Thank you, Anita. Thank you once again. Happy birthday.
Thank you, ma'am.
और कौन बचा? अभिषेक कहाँ चला गया? Abhishek, where are you? Okay, anybody else want to say something? They are welcome if they want to say anything. Because
we also request to hear your blessings also, ma'am.
Your cooperation is needed, sir. I am very much thankful to you. You have conducted very well, sir. Very well, sir. Very well organized and very well conducted by you, sir. I am very much thankful to you, sir. I have not given the vote of thanks to you, sir, but I extremely and heartily you give the vote of thanks. Thank you very much, sir.
Thank you.
अब आप बोलिए सर, आपको जो फीडबैक के बारे में बोलना है, क्योंकि बहुत लोगों की क्वेरी है कि फीडबैक फॉर्म भेजिए और उसका एक टाइम लिमिट बता दीजिए सर कब तक.
I would like to has been already posted on the chat box.
Okay, sir.
Please, all the participants could access the chat box. Yeah, after the submission of the link, you'll immediately receive the certificate on the email ID which has been filled during the Google form link. Please fill up the exact email ID in the link so that the certificate can be generated and received in your proper mail ID. Apart from that, I hope so as an organizing members for the keynotes, as per the suggestion of Dr. Vikas Dubey, we also been created a link for organizing team as well as for the keynote speakers with a wonderful certificate, which will be provided by Vikas sir. I hope he will be giving the link soon to the organizers as well as to the keynote speakers.
Thank you very much, Subhra ma'am.
Shubha madam को भूल गए.
Shubha ma'am.
Thank you, Shubha. Deshmukh sir है तो thanks to Deshmukh sir, geology Deshmukh sir. If you want to say anything, you are welcome, sir. Deshmukh sir.
Yeah, thank you very much for this, for inviting me to talk about coronavirus. And this was actually very important, and not only organizing this type of webinar, but I think now we have to understand to make such type of event or such type of conference. I think it's every institute should continue this type of conference, not on a specific time, but I think every month at least one lecture by someone who want to give presentation of some recent findings or whatever. So it was actually my first experience to give a webinar is online. However, the discussing in front of computer and not observing in front of you the audience, it was a little bit difficult for me. So I was just stop in the beginning.
But it was very nice,
I
sir.
feel the quality of the this platform is very good, and it's a good free institute to continue such type of webinar or anytime when they want to organize some lecture on some specific topic on a specific event. At least one presenter should come and present something special which should be useful for the students.
Yes, sir. Thank you very much, sir. It is on YouTube. You can see your lecture also, sir. It is streaming on YouTube. We will send you the YouTube link, sir.
Sure,
we will
sure.
send you the YouTube link. You can see that how clearly you have explained everything, sir. Thank you very much.
Thank you very much. Thank you.
Sir. Thanks to one and all.
Thank you to one and all.
End कर रहे हैं meet को.
Thank you, Khwaja sir.
Thank you, sir. We are ending the meeting. Okay. Thanks, everyone.
Thank you, sir.
End for a